as x approaches infinity of this one? Well, if we look at the picture, as x approaches infinity, what's it going to on the y? 2, the horizontal asymptote. Well, if I didn't have the picture, I know I could look at this, and what would I do?
Plug in infinity.
Yeah.
2/1.
Yes. These are same heavy, right?
Yes.
And if it's same heavy, then it's leading coefficient over leading coefficient, so that's 2/1, so y equals 2. Now, we're going to do like we did yesterday, and we're going to show why that is the way it is.
So you divide by infinity again?
Well, you divide first by x squared.
What?
On everything.
Remember, the rule was
yeah.
divide every term in the numerator and denominator by the highest power of x. So that would be limit as x approaches infinity. Let me put this over here. Limit as x approaches infinity of 2x squared over x squared, 7x over x squared, 6 over x squared, and so on.
Can we get rid of the 6 over x squared? Maybe.
So simplifying this, that becomes 2 plus 7 over x plus 6 over x squared.
You guess not.
1 over 5 over x plus 6 over x squared. Now when you plug in infinity, yes, you can get rid of those. Because when I actually plug in infinity, I get...
to 0.
That's right. Everything that's divided by infinity goes to 0.
Which leaves 2 and 1.
There you go.
Oh, I accidentally didn't write small.
Yeah, me either. I just put x equals infinity and then just wrote out equal.
So that is why when it's same heavy, that it's going to just be leading coefficient over leading coefficient. It's because when you plug in infinity, everything else goes away.
Did you click the record button?
I hope so. I think I did. Hi, yes, I did. Hi, Harvey.
I didn't remember.
That'd not be good if you didn't.
Yeah.
I mean, there's only one.
One problem, it would have been okay. Oh, we good?
Yes.
All right. So for the next one, let's look at the picture. As x approaches infinity, so as x goes this way, what's y doing?
Going one direction. Going down.
Infinity is to the right,
Oh. It's going up.
so it's going up. Yes.
Infinity.
Yeah. As I continue to go this way,
Yeah.
that would go up. This is to the right.
Sorry.
No, it's good.
Do we have to do all that plugging in?
Yeah.
Yep. Just this once.
Are we going to have to plug in infinity on the test?
You might have to once.
Oh, wait. What? Equals infinity.
Yeah, as x approaches infinity, it's going up forever.
But the actual problem equals infinity?
The limit does. So then we divide everything by x.
By x or
Oh.
X, because remember it's divide every term in both the numerator and the denominator by the highest power in the
I thought
denominator.
it was
Yeah, me
the
too.
highest power.
Highest power in the denominator.
Oh, yeah, that was a bad decision where I wrote that. Oops. I kind of wrote it like right in the middle, like the biggest I've ever written on this page. Oops. Actually,
So, simplifying, you get x plus 3 plus 2 over x.
Wait. Oh, yeah.
1 minus 1 over x.
I'm going to be thrown
We are going to throw it. So anything divided by infinity goes to 0.
Yes.
So these basically go away.
There's infinity plus 3.
Yeah. So if you have infinity and you add 3 to it,
It's still infinity.
it's still infinity. And then at the bottom you have 1, so notice we get infinity. That's why. That's why it's a slant asymptote if it's top heavy.
I'm so glad we never had to know the line of that.
But now you,
Who invented math?
me.
Dumb people.
She just called me dumb.
Who invented math? You didn't invent it.
I invented it. I did.
Wait, do you remember the TikTok I sent you of the person who created calculus?
Okay. So now we're going to talk about, well, what if it approached negative infinity?
Then you do the same thing, just the other direction. Well, it's 2.
So, yeah, like on this top one, if I approach x, the limit as x approaches negative infinity just means I'm approaching that horizontal asymptote from here, but that's still going to be 2. You're absolutely right. And it's still same heavy.
Does he need to prove why?
We already did this. I'm not going to do it again.
Cool.
But if we divided the top and the bottom by x squared, we would see that indeed it is 2. What about this one?
It's infinity.
Negative infinity. Now, this one, if you didn't have the picture, I mean, with the picture, it's kind of easy to tell because as you're going to the left, it's going down forever. Yes,
Would we plug in negative infinity?
you would plug in negative infinity. So that's why it's going to turn out negative infinity.
Because it's going toward negative infinity.
Yes. That makes sense? Good. All right. So based on what we have just seen and what we know graphically about functions above, would approaching negative infinity make a difference in the result of our limits?
No.
Not really, but kind of.
So approaching negative infinity does not make a difference if the graph contained a horizontal asymptote, but if we,
You put the
I know, but if we approach negative infinity, it does make a difference if the graph contains a slant asymptote.
I have to make announcements again.
Oh, poor you.
I don't know why you just don't ask when I want to do it. Because I've
Well,
asked.
you're going to be doing it in 2 weeks because Kennedy got next week.
Well, how do you know? I've asked like 4 times when I'm doing announcements
Really?
and no one
What
ever
do you have
responds.
Okay.
It's fine.
So for this next one, limit as x approaches negative infinity. What kind? Same heavy, bottom heavy, top heavy.
Bottom.
Bottom.
So it's
Same.
1 equals.
Same.
Oh, they moved the X.
Yes, you gotta be careful.
They moved
It's
the
same heavy because it's x squared and x squared. So what is our limit?
Negative
Negative
2/3.
Very good.
We're smart.
You are smart.
Cool.
So that's because it's same heavy.
Top heavy.
And
But
it's
we have
just
to
the
include-
horizontal asymptote. So it does not matter at all that we're approaching x from the left-hand side.
We don't have to explain.
Now the
anything.
next one's top heavy.
Not unless it says.
So that's just infinity.
Top heavy.
Wait, it would be negative infinity.
Okay, this one is top heavy, so we have to figure out if it's negative or positive infinity.
So we plug in.
So, yes, we could do it the long way, or we could just, first off, I'm going to write that it's top heavy. So there's a slant asymptote. So since the degree of the numerator is exactly 1 higher than the degree of the denominator, that means that it's going to be a line.
Okay.
That our slant asymptote is going to be a line. Because when you divide x squared divided by x, you get just x. So it's like y equals mx plus b.
Okay.
Okay. Let me write that down.
I say I already knew it was a line.
Yes. The numerator
Ashley, put on your shit.
is 1 greater than the denominator.
Wait, did you curse your portion? Yeah, you did.
Oh, hers are like dirty.
So the graph has a slant asymptote that is a line. The